For lesson 2.1d, we are going to be talking about simplifying with laws of exponents. And our goal for this lesson is to learn to simplify more complex expressions involving the laws of exponents. Now, one thing I want you to make sure that you note is that you want to, in order to simplify these expressions, you want to group like terms together, then use the laws of exponents to simplify. And we'll take a look at some examples to show exactly what that is going to look like. So in our first example, we have 4x squared times 2x cubed. And so we're multiplying all four of these things together. And what we want to do is we want to rearrange the order, and so that we're grouping the like terms together. So our like terms are going to be 4 and 2, and then x squared and x cubed. And so we're going to want to rearrange the order in which this is written in to group our like terms together. So what that means is we're going to have 4 times 2, let's try that again, 4 times 2 times x squared times x cubed. So now with this 4 times 2 in the front, guys, don't overthink this. 4 times 2, don't think about laws of exponents at all. 4 times 2, we know that's just 8. 4 times 2 is 8. And then for x squared times x cubed, that's where we're going to want to remember our laws of exponents. When we're multiplying powers with the same base, we want to add the exponents together, and we get x to the 5th. And that's it. We've completely simplified that first expression. Let's take a look at a second example. For our second example, we have the expression x squared times y, all to the 4th power. Now, keeping in mind our laws of exponents, when we're taking the power of a power, we're going to multiply the exponents together. So one thing to note is that behind this y, there's an invisible 1 for an exponent there. We don't write it, but if you want to include it there to help you remember what you're supposed to do, then go ahead and do so. Now, when we go through and do these problems, we have to remember that this exponent here gets applied to both of our terms inside the parentheses. So we could almost rewrite it as x squared to the 4th times y to the 1st to the 4th. Now, I wouldn't expect you to always show that line of work, but you can if you want to. And now it's just a matter of using our power of powers rule. When we have this power here, x squared to the 4th power, we're going to multiply our exponents together to get x to the 8th. And then for our second power, we have y to the 1st to the 4th power. Again, 1 times 4 is going to give us 4, giving us y to the 4th. So our final answer there is going to be x to the 8th, y to the 4th. For our third example, we have the expression 6x to the 7th, y to the 9th, over 2x to the 4th, y squared. Now, if we remember the note that we wrote down earlier, we want to group our like terms together, and we have 3 pairs of like terms. We have our whole numbers here, or our integers here. We have our x terms here, and then our y terms at the end. And so we actually can go ahead and break this down into 3 separate fractions. So we could have 6 over 2 times x to the 7th over x to the 4th, multiplied by y to the 9th over y squared. And now we can take each one of these fractions and simplify it. 6 over 2. Again, we're not overthinking this. 6 divided by 2, that's just going to give us 3. Then x to the 7th over x to the 4th. We subtract our exponents because we're dividing powers with the same base. We get x cubed. 7 minus 4 gives us 3, so that's how we get x cubed. And then for our last term, we have y to the 9th over y squared. 9 minus 2 is going to give us 7 for our exponent, so we end up with y to the 7th. And with our fourth example, we have the expression 4x to the 5th y over 16xy to the 4th all of that to the third power. Now for a problem like this, what you want to do is you want to completely simplify as best as you can what's inside the parentheses, then apply this third power that's on the outside of the parentheses. If we remember our order of operations, we do what's inside the parentheses first, then we take care of our exponents. So we're going to separate this big expression inside the parentheses into into three smaller fractions. So we have our integers, we have our x variables, and our y variables. So we have 4 over 16. Multiply that by x to the 5th over x. Multiply that by y over y to the 4th. And then that's to the third power. Now we have these three fractions, and we want to simplify each of them. Something, again, you can do if you want. Put our one exponent above our variables that don't have a power with them. And now we're going to simplify our three fractions. 4 over 16, that's just going to simplify to 1/4. X to the 5th times x to the x to the 5th over x to the 1st. 5 minus 1 is going to give us x to the 4th. Multiply that. Y to the 1st over y to the 4th will give us y to the negative 3rd. If you want to make that into a positive exponent, you can, but I would encourage you to leave it as a negative exponent for now. We wrap that in parentheses with our third power on the outside. And so now our third power here is still going to get applied to all three of our powers, all three of our terms inside. So we're going to apply the third power to the 1/4, to the x to the 4th, and to the y to the negative 3rd. So when we do that, I'm going to put my 1/4 in parentheses to have 1/4 third, 1/4 to the third power gets multiplied by x. 4 times 3 is going to give me 12. Multiply that. Negative 3 times 3 is going to give me y to the negative 9th. Some teachers might be okay with an answer like that, but let's go ahead and take it one step further to show what it would look like using just a single fraction bar and making sure all of our exponents are positive. If we look at our fraction, this 3 gets applied to the 1 and to the 4. So 1 to the 3rd is just 1. 4 to the 3rd, just going to leave as 4 to the 3rd for now. Now up here, x to the 12th is the same thing as x to the 12th over 1. So I multiply that by x to the 12th. Y to the negative 9th, we'll put that over 1 as well. And we remember to make this positive, we want to move that to the denominator. So I end up with y to the 9th in the denominator. Let's clean this up a little bit. So we get rid of our 1 times x to the 12th, and we get x to the 12th power over 4 cubed y to the 9th. We'll take a look at two more examples. Our first of our last two examples is going to be 5x squared y times the quantity 2x to the 4th y to the negative 3rd. Again, we're just grouping our like terms together. Everything's being multiplied together up here, so we can rearrange the order a bit. And so we're going to put our integers out front, where we have 5 times 2. Then we'll put our variables next, starting with our x variables, x squared times x to the 4th. Then finally our y variables, where we have y times y to the negative 3rd. I apologize for the auto zoom, not sure why that's going on. But 5 times 2, let's not overthink it, 5 times 2 is going to give us a value of 10. X squared times x to the 4th. We add our exponents when we're multiplying powers with the same base to give us x to the 6th. And then finally y times y to the negative 3rd. If we want to put a 1 up here to remind us that we're taking 1 minus 3 1 minus 3 is going to give us negative 2. So we end up with y to the negative second power. Now, if you had to take this a step further and rewrite this using only positive exponents, we would again make this into a fraction. And the only part that gets moved to the other side of the fraction bar is the term with the negative exponent. So we're going to leave 10, and we're going to leave x to the 6th in the numerator, but the y to the negative second, that's going to get moved to our denominator to turn our exponent positive. So our final answer here then is going to be 10 x to the 6th over y squared. And that's it. There's nothing more we can do to simplify that. One more example to look at. For our last example, we have the expression 2x to the 4th y to the negative 4th over 8x to the 7th y cubed. Again, what we want to do is we want to separate into 3 separate parts. One part for our integers, one part for our x variables, one part for our y variables. And if there's more variables, just separate it into more parts. So we have 2 over 8 multiplied by x to the 4th over x to the 7th multiplied by y to the negative 4th over y cubed. We're going to separate one part at a time. We're going to simplify one part at a time. 2 over 8 simplifies to 1/4. X to the 4th over x to the 7th. Subtract the exponents because we're dividing powers with the same base. 4 minus 7 is going to give us x to the negative 3rd. Multiply that. Y to the negative 4th over y to the 3rd. Again, subtracting. Negative 4 minus 3. Negative 4 minus 3 is going to give us y to the negative 7th power. Now again, if we want to make this into an expression where we have only positive exponents, we'll put this over 1 and this over 1. We'll move this and this down to make their expressions positive. So we end up with 1 over 4x cubed y to the 7th. And that's it. That's our final answer. If you guys have any questions, please write them down. We can talk about them in class. Otherwise, go ahead and work on your practice, and we'll talk about this more tomorrow.